This is my video proof that a sequence will converge to a point if and only if each neighborhood of that point is going to contain all but a finite number of terms from the sequence. So we're going to go ahead and suppose our sequence converges to a point A. Since this is an if and only if, we actually have to go both directions with the proof. So let's start by assuming that our sequence converges to a point A, and then we'll go ahead and let Q be just some neighborhood of A. So by the definition of a neighborhood, there's going to exist epsilon greater than 0 such that the interval from a minus epsilon to a plus epsilon is a subset of Q. Well, since our sequence converges to a and epsilon is in fact greater than 0, there's going to exist a big N in the natural numbers so that for little n greater than or equal to big N, the absolute value of a sub n minus a is going to be less than epsilon. So we have for little n greater than or equal to big N, a minus epsilon is less than a sub n is less than a plus epsilon. So that means that our a sub n is going to be part of that neighborhood. Or it's going to be part of that interval, which is a subset of that neighborhood. So Q is going to contain all the terms of a sub n after little n is greater than or equal to big N. So it's going to contain all of them except a few of the ones that, or except possibly some of the ones that occur in A1, A2, all the way to AN minus 1. Therefore, Q is going to contain all but a finite number of terms. Now we got to go the other way with it. So now we would show that if each neighborhood contains, or if each neighborhood of A contains all but a finite number of terms in a sequence, then that sequence converges to A. All right, well, first pick epsilon greater than 0, and then we're going to go ahead and let Q equal the interval A minus epsilon to A plus epsilon, and we'll call it a neighborhood of A, and assume it contains all but a finite number of terms in the sequence. All right, well, that's going to imply that there's going to be some set S. So we're going to go ahead and set up S as basically the set of all the n's, so that if a sub n is not in Q, then n is in S. So we'll go ahead and let n equal the maximum of S plus 1. Now, if little n is greater than or equal to big N, then n is not going to be an element of S, so by the definition of S, a sub n would have to be in Q. That is, a minus epsilon less than a sub n less than a plus epsilon. This is equivalent to that absolute value from earlier, that the absolute value of a sub n minus a is less than epsilon. So for little n greater than or equal to big N, we have the absolute value of a sub n minus a is less than epsilon. Therefore, our sequence converges to A by the definition of converging to a point A. Thank you.